Hey everyone, welcome. Today, we're going to dive into something that's literally inside almost every electronic device you own: resistors in series. If you've ever been curious about what's really going on inside your gadgets, well, you're in the right place. So let's just start with a simple question, right? What actually happens when you connect electronic components one after another like they're holding hands and forming a single file line? This one simple idea, well, it's the key to everything we're talking about today. All right, here's our game plan. We're going to start with the absolute basics. Then we'll learn a couple of super simple formulas, see how this stuff is used in the real world, and then we'll put it all together with a final challenge. Let's do this.
Visit youtube.com/avidsystem and don't forget to subscribe.
Okay, let's lay down the foundation. We're starting at the very beginning, but don't let its simplicity fool you. This one concept is the bedrock for everything else we're going to learn.
So what is a series circuit? Think of it like a one-lane highway with absolutely no exits. The cars, or in our world the electrical current, have no choice but to follow that single path, one right after the other. That is the crucial takeaway here: one single path. Yeah, the easiest way to picture this in your head is as a daisy chain. Each component is linked directly to the next in one long, unbroken loop. And here's the kicker: if any single link in that chain breaks, it's game over. The entire circuit just goes dead. That's how important that single path is.
Okay, so we get what a series circuit is, but how do we actually, work with it? How do we measure its total effect? Well, that brings us to our very first rule: calculating the total resistance.
And you're going to love this because the rule is so simple. The total resistance is just the sum of all the individual resistances. It's like all the resistors team up to create one single super resistor that the circuit's current has to push against.
And look, the process couldn't be easier. You just identify the value of your first resistor, R1, then your second, R2, your third, R3, and so on. Then you just add them all up. That gives you your total resistance, RT. It's really that simple. Identify and add. You can't go wrong.
Let's do a quick one. If you have a 10 ohm, a 22 ohm, and a 47 ohm resistor, what do you get? Yup, 79 ohms. See? I told you this part was easy. All right, so we've got the resistance part figured out, but what about the electricity itself? What's the current doing? What's the voltage doing as it flows through our little daisy chain? Let's find out. This right here, these are the two golden rules of series circuits. You got to remember these. Because there's only one path, that one-lane road, the current is exactly the same through every single component. But the voltage, that gets split up. Each resistor takes its own little share of the total push from the power source. Now, this idea actually has a fancy name. It's called Kirchhoff's voltage law. But the best way to think about it is like a pizza. The battery is the whole pizza, and each resistor gets its own slice. When you add up all those slices, you get the whole pizza back. No voltage is ever lost or created out of thin air. It all has to add up.
Now, this idea of voltage getting divided up isn't just some weird little quirk of physics. It's actually one of the most useful tricks in the entire world of electronics. It's called the voltage divider.
So why does this even matter? Well, imagine you have a 9-volt battery, but you need to power a tiny little LED that can only handle 3 volts. What do? You use a voltage divider to create that perfect 3-volt supply just for that one part. It's like having a custom power source for every single component in your circuit. And of course, there's a secret weapon for this: the voltage divider formula. This little beauty lets you calculate the exact voltage you'll get at any point in the chain without having to do a bunch of extra steps. It is a circuit designer's absolute best friend. All right, you've learned the rules, you've seen the tricks. Now it's time to put all your new skills to the test. Let's tackle a complete circuit problem together from start to finish. Here is our scenario. We have a 12-volt power source. It's connected to a 100-ohm resistor, we'll call it R1, and a 300-ohm resistor, R2. Our mission, should we choose to accept it, is to find out everything we possibly can about this circuit: the total resistance, the current, and the voltage across each part. And we are going to crack this case in 3 simple steps. First, we find the total resistance by just adding them up. Second, we'll use our trusty friend Ohm's law, remember, voltage equals current times resistance, to find the total current. And finally, we'll zoom in and find the voltage drop across each individual resistor. And here's the solution. Let's walk through this table. Start with that total row at the bottom. The total resistance is 100 plus 300, which is 400 ohms. Now, using Ohm's law, our 12-volt source divided by 400 ohms gives us a total current of 0.03 amps. Okay, now look at the rows for R1 and R2. Notice the current column? It's the same for both, 0.03 amps, just like the rule says. And the voltage drops? R1 takes 3 volts and R2 takes 9 volts. Add them up and you get 12 volts. It all checks out perfectly.
So there you have it. You've totally mastered the single path. You get how it all works. But that just leaves one really big question. What happens when the path splits?
Thanks for watching.